Good day, teaching everyone. Now we will proceed to the chapter 20.4, the life cycle of cosmic material. Okay, we have two concepts here to be discussed in this video. We have two learning objectives. By the end of this video, you will be able to explain how interstellar matter flows into and out of our galaxy and transforms from one phase to another, and understand how star formation and evolution affects the properties of the interstellar medium. And then, second one, we can now explain how the heavy elements and dust grains found in interstellar space got there, and describe how dust grains help produce molecules that eventually find their way into planetary system. Now, we will proceed to the flows of interstellar gas. Okay, the most important thing to understand this interstellar medium is that it is not static. Okay, remember that, because interstellar gas orbits through the galaxy, and as it does so, it can become more or less dense, or hotter and colder, and change its state of ionization. And then, a particular parcel of gas may be neutral hydrogen at some point, then find itself near a young hot star and become part of an H2 region. Okay, here please observe the picture. Okay, figure 1 shows the large-scale distribution of interstellar matter. And remember that this image is from a computer simulation of the Milky Way galaxy's interstellar medium as a whole. Okay, here in the picture, okay, so as we observe that the majority of gas is visible as greenish colors. Okay? Nakikita nyo ba yan? Did you observe that? And it is neutral hydrogen. And in the densest region, makikita natin sa densest regions in the spiral arms, okay, shown in what color? Yes, yellow. And then the gas is collected into giant molecular clouds. And then sa low density holes naman in the spiral arms, nakita natin na blue yung color. And ito yung po yung result ng supernova explosion. Okay? Understand? Now, given a time in the Milky Way, the majority of the interstellar gas by mass and volume is in the form of atomic hydrogen. And the much denser molecular clouds occupy a tiny fraction of the volume of the interstellar space, but add roughly about 30% to the total mass of gas between the stars. And conversely, yung mga hot gases pa natin, nagpo-produce po siya ng supernova explosions that nagko-contribute as a negligible mass but nag-occupy a significant fraction of the volume of interstellar space. Yung H2 regions natin, though they are visually spectacular, but they constitute only a very small fraction of either the mass or the volume of interstellar material, okay? However, yung interstellar medium natin, it is not a closed system. Take note for that. Take note of that. The interstellar medium is not a closed system because gas from intergalactic space constantly falls onto the Milky Way due to its gravity and adding new gas to the interstellar medium. But conversely, in giant molecular clouds where gas collects together due to gravity, the gas can collapse to form what? New stars, okay? And this process interstellar matter into stars, okay? Remember that as the stars age, evolve, and eventually die, yung massive stars naglulose ng large fraction of their mass, and low mass stars lose very little, okay? And then yung supernova explosions have so much energy that they can drive interstellar mass out of the galaxy and back into intergalactic space. And thus, therefore, the total amount of mass of the interstellar medium is set by competition between the gain of mass from intergalactic space and then the conversion of interstellar mass into the stars and loss of interstellar mass back into intergalactic space due to supernova. Okay? At itong proseso na ito, and this process, may tawag po ito, it is known as a baryon cycle. Baryon is from the Latin word for heavy. And the cycle has this name because it is the repeating process that the heavier components of the universe, which is the atoms, undergo. Okay? Now, we will proceed to the cycle of dust and heavy elements. Okay? Now, we have here a question. Okay? What stars do for a living? Okay? The answer is, it is fuse heavier elements from lighter ones, producing energy in the process. Okay, remember that as stars matured, they begin to lose some of the newly made elements to the reservoir of interstellar matter. The same po yan sa dust grains. Yung dust, nabuform siya when yung grains can condense in regions where yung gas nagde-dense at nagkukul. Then, one place where the right conditions are found in the wind from luminous cool stars, okay? So here, the surface of dust grains, which would seem very large if you were an atom, provide nooks and crannies, where this atom can stick long enough to find a partner and form a molecule. So, think of the dust grains as interstellar social clubs where lonely atoms can meet and form meaningful relationships. Diba? Sana all. Eventually, the dust grains become coated with ices. And the presence of the dust shields the molecules inside the clouds from ultraviolet radiation and cosmic rays that would break them up. So, when stars finally begin to form within the cloud, they hit the grains and evaporate the ices. And the gravitational attraction of the newly forming stars also increases the density of the surrounding cloud material. And marami pong chemical reactions can take place on the surface of grains in the gas surrounding the newly forming stars, and these areas are where organic molecules are formed. Okay? Recent observations from space have shown that water is abundant in dense interstellar clouds, since stars are formed from this material, isn't it? And water must be present when solar systems, including our own, come into existence. And the water in our oceans and lakes may have come initially from water locked into the rocky material that accreted to form Earth. Alternatively, the water may have been brought to the Earth when asteroids and comets formed from the same cloud that made the planets later impacted. And then, yung scientists naman, estimate nila that yung one comet might impact every 1,000 years during Earth's first billion of years. That would have been enough to account for the water we see today, okay? Of course, both sources may have contributed to the water we now enjoy drinking and swimming, okay? But any interstellar grains that are incorporated into newly forming stars instead of the colder planets and smaller bodies around them will be destroyed by their high temperatures. But eventually, each new generation of stars will evolve to become red giants and with stellar winds of their own. Some of these stars will also become supernova and explode. Therefore, the process of recycling cosmic material can start all over again. And that's all. Thank you.
It was a race on my back.